Hello students, we have already discussed in the previous class what is signal. So already I told you signal is a physical quantity that varies with time, space and with any other independent variable or variables. Or signal carries some information for observation. More precisely we can say that signal is a physical quantity that varies with time, space with any other independent variable or variables. So signal itself carries some information for observation. So how will you represent the signal, that is important. So as far as the signal is concerned, already I told you the signals in previous class S1 of t, suppose S1 of t equal to 5t and S2 of t is your suppose 10t square, and here t is your independent variables. So we can express the signal in a continuous signal. So S1 of t equal to 5t square, here t is your independent variable, and this example, that means the signal varies linearly with time t, and here the signal varies quadratically, here 10t square, and the signal varies quadratically. So how will you represent signal? As far as discrete signal is concerned, in a digital signal processing, what does it mean? There are three words: digital, signal and processing. Already I told you signal is a physical quantity that varies with time, space and with any other independent variable or variables. Then digital, the word digital shall mean that how will you represent the signals, a digital signal or a discrete signal. In a digital signal, like in your digital electronics, the computer understand only binary language or machine language, that is 1 and 0, that is your a rectangular pulses may be plus 5 volt can be represented by binary 1 and 0 volt can be represented as binary 0. As far as your digital electronics is concerned or digital signal is concerned. As far as discrete signals, so we will represent the discrete signals, that means the width is negligible, we can consider for the every values of n, that is your amplitude values. So that is called the discrete signals. So in today's class we will discuss about how we represent the signals, that is your discrete signals. As far as digital signal is processing is concerned, what is DSP? There are three words refers that digital signal and processing. The word digital signal processing means what? The signal can be represented in there are different types of methods are there. How will you represent the signals? After representation of the signals, then we have to process these signals in a DSP processor or block diagram of digital signal processing. Already I told you that is what how analog signal can be processed by means of digital signal processor. First of all, there is an analog signal, and in case of A to D converter, a continuous signal can be converted into a digital one. Then after that, there is a DSP processor. In a DSP processor, what happen? We can extract some useful information by means of processor. Then after output of the DSP processor is a digital your digital signal. Your original signal was analog signal. Then we will convert this digital signal into analog one by means of D to A converters. In this way, we can process these analog signals by means of a DSP block diagram of digital signal processing. That's already I told you in a previous class. Now today, how will you represent the discrete signals by means of, there are so many methods will represent the discrete signals. Here, how will you represent the discrete signals or digital signals? So there are four types of representation of discrete signals or digital signals in case of as far as digital signal processing is concerned. So first one is your what? That is your graphical representation. Graphical representation. Graphical representation. And second one is your what? That is your functional representation. Functional representation. And third one is your tabular representation. Tabular representation. And fourth one is your sequence representation. Sequence representation. Sequence representation. So there are four ways. First of all, how you represent the signal is very important. If signal is expressed in either of these four forms, maybe your graphical representation, maybe your functional representation, maybe your tabular representation, and maybe your sequence representation. So what does it mean? That is your graphical representation. We will go through one by one. First, number one, that is your graphical representation. graphical representation. Graphical representation of discrete signal. In a graphical representation, so in a graphical representation, the x axis we can say that is your n, and y axis, suppose we can say if the n is your x axis and y axis is nothing but x of n. In graphical representation, so I can write here, this is your n equal to 0 and this is your -1, let this is your 1, this is your 2, 3, this is your 4, 5. Suppose I can say this amplitude level is 1, this is your 2 and this is your 3. So I can say at n equal to -1, x of n equal to 1 and n equal to 1, suppose that is your 2 here, n equal to 2 that is your 3 here, and n equal to 3 this is 1 and n equal to 4 that is your 2. Okay. So this is a graphical representation of a discrete signal. So this representation of discrete signal shows that n equal to -1, n equal to -1, x of n is how much? X of -1 equal to n equal to -1, x of -1 is your how much? X of n equal to -1, x of -1 equal to how much here? X of -1 equal to 1, x of -1 equal to 1. Similarly, n equal to 0, n equal to 0, nothing is there, n equal to 0, that is your x of 0 equal to 0. Similarly, if I will say n equal to 1, n equal to 1, n equal to 1, x of 1 is how much? X of 1 equal to 2. Similarly, for n equal to 2, n equal to 2, x of 2 is how much? X of 2 equal to your equal to 3. Similarly, n equal to 3, x of 3 equal to 1. Similarly, n equal to 4, x of 4 equal to, that is your 2. That's what we can say that this is a graphical representation of discrete signal. Okay. So then go to functional representation. Functional representation. Number 2, that is your functional representation. Functional representation. Functional representation. So what is functional representation? Suppose in a graphical representation is given, so that is sufficient information for you. So you can you know that where is for n equal to 0, what is the value of x of 0? If n equal to 1, x of 1 is how much? Already given. So all the data has already been given in graphical representation. So in this way we will represent the discrete signal by means of graphical representation. So as far as functional representation is concerned, there is no, this figure is not given. In functional representation, from this information I can represent the discrete signal in functional representation. So here I can write x of n equal to 1 or n equal to what? Where is 1? -1 and then 1 and then 3. So I can write n equal to -1, then 1 and 3 and 3. Okay, x of n equal to 1. Similarly, I can write x of n and then here also, then x of n equal to 2. If x of n equal to, where is it 2? Only n equal to 4. For n equal to 4, x of 4 equal to 2, or n equal to where is it 2? That is your n equal to 1 and n equal to 4. 1 and 4 for n equal, x of n equal to 2. Similarly, 3, x of n equal to 3 for, where is 3? So that is only 2, n equal to 2. And then 0 you can write elsewhere. Okay. So only this information is given. If it is a functional representation, x of n equal to 1, that means you will understood that for n equal to -1, n equal to 1, n equal to 3, the value of x of n equal to 1. For n equal to 1 and 4, the value of x of 1 equal to 2, x of 4 equal to 2. Similarly, for n equal to 2, that means x of 2 equal to 3. Then 0 elsewhere, except this -1, 1, 3, 4, 2, all the value irrespective of any value of n, the x of n will be 0. Elsewhere means what? We x n 5 equal to 0, x of -2 0, -3 0, any value of n except this, the value of x of 5 or -2, any value of x of n, the value will be 0. So this is all about your functional representation. So number 3, that is your tabular representation. So how do you represent a discrete signal in a tabular representation? Number 3, that is your tabular representation. Tabular representation. So in a tabular representation, so there is a table. One is n, another one is your what? X of n. This is your tabular representation. In tabular representation, it may be given -2 or -1, -3, 0, then 1, then 2, then 3, like this. So in tabular representation, n equal to -2, for n equal to -2, that is 0. So here x of n equal to 0. N equal to -1, that is 1, n equal to 0, 0, n equal to 1, that is 2, n equal to 2, that is 3, and n equal to 3, that is your what? That is 1. And also n equal to 4, the value is what? That is your 2, This is your tabular representation. So this much of information is given as far as tabular representation of discrete signal is given. Only this in tabular representation we can represent the discrete signal in this manner. This is a tabular representation of a discrete signal. So then you will go for what? Sequence representation. In case of sequence representation, of discrete signal. So how you represent the discrete signal in sequence representation? So in sequence representation, number 4, that is your sequence representation. Sequence representation. In sequence representation, only x of n is given. X of n equal to, only the value is given. X of -1, x of 0, x of 1, x of 2, x of 3, only the value of given. So you will identify in that information for what value of n, means what value of n equal to 0, what value of x of 0, for n equal to 1, what value of x of 1, like this. In sequence representation, so that is your what? So here 1, 0, 2, then 3, then 1, then also 2, like this. For this example also I am writing here, in sequence representation, here there is an arrow mark. This arrow mark indicate for n equal to 0. So this arrow mark indicate for n equal what? N equal to 0. So that you will understood that if arrow mark is given, that you will understood that for n equal to 0, that means for n equal to 0, x of 0, that is 0. So right side of this arrow mark for n equal to 1, 2, 3, etc., and left side of the arrow mark for n equal to -1, -2, -3, just like your number line. In number line for 0, 1, 2, 3, and at left side of 0 there is -1, -2, -3. Similarly, in case of sequence representation, if the arrow mark is given, so you will understood that this value is for what? For n equal to 0. So that's why for n equal to 0, x of 0, that is 0. Then automatically next values for n equal 1. For n equal 1, x of 1, that is 2. For n equal 1, x of 1, that is 2. For n equal to this, here n equal 1, here n equal to 2, n equal to x of 2, that is 3, x of 2, that is 3. For n equal to 3, n equal to 3, that is 1, n equal to 3, that is 1. Similarly, n equal to 4, that is 2. For n equal to 4, that is 2. From here, from this arrow mark, you will understood that for n equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to 4. For right side of the arrow mark indicate for n equal to 1, 2, 3, 4, etc. Left side of arrow mark, the value is for n equal to -1, -2, -3 like this. Left side arrow mark, that is only one value, that is 1. You will understood that for n equal to here, the n equal to -1, x of -1 that is 1, x of -1 that is 1. This is all about your sequence representation of a discrete signals. So now this is all about, there are 4 different ways how you represent the discrete signals by means of your graphical representation, then functional representation, third one is your tabular representation, and fourth one, that is your sequence representation. So thank you students. Then next class we will study the elementary discrete signals, that is your different types of elementary signals which will play a great important role in communication or signal processing systems, that is impulse sequence, ramp sequence, step sequence, your exponential sequence, sinusoidal sequence. There are so many basic signals which are play a very great important role in communication and signal processing systems. Then how you apply these elementary signals like your impulse sequence or sample sequence will represent impulse in terms of your step signal, we will express step signal in terms of impulse signals. So there are varieties of signals are there, means what? The elementary signals, how you represent these elementary signals, and what is the necessity of these elementary signals, and how you apply these elementary signals in a signal processing and communication systems. So thank you.